Hey guys, welcome back to my YouTube channel. So say we have a function that looks something like this, right? We're trying to find the Taylor series for it, okay? Taylor series for this. Specifically, it has to be centered at 5, okay? So centered at 5, and so the equation, right, for a Taylor series, the formula for that looks something like this. And so we have an A here, right? And the A is basically what it's centered at. So the A in this case is going to be equal to 5 as shown from here, okay? So we have to find the Taylor series of this. So we have to kind of use this formula. So first we start off by looking at the derivative of 1 over x. So if we have f of x equals to 1 over x, this can be rewritten as x to exponent of -1. Okay, so this will help us find the derivative easier. So derivative of this, we take this -1 down, right? And it's going to be -1 times x to the exponent of -2. Okay, that's the derivative. Now we have to find a second derivative because we want to know, like, kind of see if there's a trend with nth derivative. We're going to see if there's like a trend for that. So we're just going to continue this pattern. Second derivative, we have -1 here, right? Take down the -2 again. So -2 times x to the exponent of -3 because we subtract 1 from the exponent, right? Remember, power rule for derivative. And so now we look at third derivative, so same thing. Very similar concept. So down this -3. Okay, take down -3, we get -3 here, and then times x to the exponent of -4 because we subtract 1 from this -3. And then the fourth derivative, we will get -1 times -2 times -3, take down the -4, x to exponent of -5 minus 1 from the 4, and let's do 5. Just do 5 to see if we can find a pattern. So -1, -2, -3, -4, and you know why I didn't multiply them together? Because we can kind of see some sort of factorial here, right? So that can be part of our pattern. So -5 goes down, it's going to be 6 because we subtract 1 from this -5, so -6. Okay, so we get this, and we can see that this is the first derivative. So in this case, n is going to be equal to 1, right? Because here n is like the derivative, okay? So n equals 2 here, second derivative, n equals 3, third derivative, n equals 4, fourth derivative, n equals 5, fifth derivative. So now we can kind of see we have a bit of a pattern, right? So if we were to write out the nth derivative, right? We look at it and we see, okay, well, let's simplify this first. So this is going to be, let's rewrite this as -1 over x squared, right? Negative exponent, just going to go to the denominator. And let's rewrite this as positive 2, right? 1 times 2 is 2, and negative, positive 2 over x cubed, right? This x cubed goes in the denominator, and this one we can rewrite as negative, well, this is 1 times 2 times 3, right? It's going to be 3 factorial. This is also 2 factorial, by the way. Let's write the factorials in. We can recognize it as factorials. This will help us recognize the pattern. And it's x to exponent of 4 in the denominator. And then this one is going to be, well, we have 1 times 2 times 3 times 4, 4 factorial, okay? And we have 1, 2, 3, 4 negatives, so it's going to be positive here. Then it's x to the exponent of 5. Likewise, for this one, it's going to be negative 1, 2, 3, 4, 5, 5 negatives of negative. And then we have this as 5 factorial, so 5 factorial, all over x to the exponent of 6. Like that. It's negative, positive, negative, right? So here in this case, we can see a pattern. And the pattern is that, well, here it's 1, right? And then n is equal to 1. Here's 2, n is equal to 2, 3, n is equal to 3. So it's like we have n factorial, okay? N factorial is going to be part of it. And then in the denominator, we have x to the exponent of some sort of number. Here it's 6, right? Here n is 5. Here it's x to the exponent of 5. Here's n is equal to 4. So it's like greater than the n, right? By 1. This is greater than n by 1. This is 4, right? 3 plus 1 is going to give us 4. 2 plus 1 is going to give us 3. So here it's saying it's like x to the exponent of n plus 1. Now considering the negative signs, we have some sort of negative 1, right? Multiplied to this, some sort of exponent of n. So let's try n first. So let's say if n is equal to 1, then that means that if n is equal to 1, then this negative 1 to the exponent of n is going to be equal to negative 1 to the exponent of 1, which is going to be negative 1. So it's going to give us the negative. Good. Now if n is equal to negative 1 to the exponent of n, it's going to be negative 1 to the exponent of 2. It's going to be 1. Good, positive. So it's like it's alternating, and hey, it works. Because let's say if n is equal to 5, put in 5 here, right? This whole thing's going to be negative because it's an odd exponent. It's perfect. Okay, so we basically have gotten it this form. Now, what we really need to find is this, right? The derivative with the a inside of it. So we have to plug in a. A is going to be 5. So if we want to find it as a, we have to basically plug it in. It's 5 right here. So plugging that in, we are going to basically plug it into our x. So plugging that in, we will get 5 to the exponent of n plus 1 like this. So we're going to get this. And so this is our f with the nth derivative evaluated at a, okay? So now we can just take this whole thing and we can plug it back in right here into this equation. So plugging that into our equation, we will get, well, we have to plug in first f, like this part, right? So basically what we found, the bottom, and also we have to write in this summation symbol. So we're going to write in the summation, just like that. And we plug this in. So negative 1 to the exponent of n times n factorial over 5 to the exponent of n plus 1, okay? This whole thing, in these brackets, I bracket it the same as this numerator, okay? And then it has to be all over n factorial, as you see in the denominator, and it has to be x minus a to the exponent of n, so we're going to copy that. X minus, oh wait a minute, a is equal to 5, so we write 5 to the exponent of n. That is because here at the beginning we said a is equal to 5, so this is going to be 5 right here, okay? So we get 5 here. Now let's simplify this a bit. So summation, and then it's going to be negative 1 to the exponent of n times n factorial all over 5 to the exponent of n plus 1 divided by n factorial. Now if we divide, we can flip, but I'll do that in the next step actually, just to show you how it kind of looks. So now let's flip it. So negative 1 to the exponent of n over 5n plus 1 times n factorial times 1 over n factorial, x minus 5 to the exponent of n, this n factorial cancels out, and then we will be left with, let's put brackets around here, it's a little better. we will be left with this times this, right? So -1 6/12n over 5n plus 1 in the denominator, right? Times 1 is it's just gonna be that number, so we don't have to write that. And there we have it. So we have found our Taylor series for the original function, okay? Centered at 5. Okay, so this is the end of the video. If you enjoyed it, feel free to give it a big thumbs up, and also feel free to let me know in the comments down below what you think about this video. And if you are new to my channel, feel free to hit that subscribe button. So this is the end of my video. I hope you have a nice day, and I hope to see you next time for another math video. Bye!